So previous lecture, we talked about binomial random variable. So binary variable means it's gonna be either yes or no, or succeed or failures, or that kinds of thing. Either 1 or 0, only 2 possible outcomes, right? We paused last time on this question, like let's say we randomly chose 20 answers and the wise number of correct answers. So those are basically we are looking for. So probability that y equals y equals some number. For example, in our these cases, we are looking for probability that y equals 2 because we are interested in you get 2 points from the exam out of 20 questions. So I was interested in, okay, what is the probability that you are only getting 2 questions right from 20 questions? The answer was this, right? And today I'm gonna talk about why this was the answer. So that is concept of binomial distribution. But before that, we need to discuss some of the concept. So out of ABCD, which has nothing to do with independence. We talk about independence in conditional probability in chapter 1 and 2, especially in chapter 2. So based on that, what would be your answer? You might want to pause this video. This independence is very important, so please study on this topic. I will leave you the answer, but please take a look at that. Please try to answer yourself first. So if x1 and x2 are independent, this is the case, okay. This is a standard method, right? Most classic. So, and another way of doing is this. So conditioning on x equal 1 or x equal 0 doesn't affect probability of x equal 2, x2 equal 1. So probability of x2 equal 1 is not affected by whether x equal 1 and whether x1 equals 0. So those are very important concepts. This is meaning independent, or using Bayes' law or conditional probability law we learned before, right? We derived this concept. So if you don't remember, please go back to chapter 2 and study this independent, and also look at chapter 1 as well. So this is another example. Suppose that you are manager of an airline, 2 passengers A and B, probability of reservation being canceled, so probability equals 10. So during the exam, and also when you are doing the homework, you should define the probability. So I said the probability of a reservation being canceled is 10%, right? Well, you can say, okay, I just want to focus on probability of a reservation not being canceled equal 90%. Then that can be your P, or it can be your P that based on your definition, So if I say, okay, I will explain in more detail. So, but try to get this answer right. So what is the probability that A's reservation is canceled, but B is not? Can you try to answer? You might want to pause this video again. I will leave it that. So let's say I say reservation being canceled equal 1. Again, you can say reservation not being canceled equal 1, but whole process would be changed accordingly. So make sure you guys got familiar with that. Or reservation being canceled equal 1 and 0 otherwise. So that is our definition, my definition, but you can choose your own definition. But final answer would be the same. So we are interested in intersection A equal 1 at the same time B equals 0. So since they are independent, how do they do that? So we just multiply this probability, right? Probability of A equal 1 times probability of B. The reason why we are able to use this formula was because they are independent. I told you guys, they are independent. Otherwise, you cannot use this formula. So this formula was coming from this one. So probability that x equal 1, intersection, so that means and, A and E, and x2 equal 1 is just multiplication of these two. So that because the 2 events are independent. So probability of A equal 1 means they are being canceled, and b equals 0 is just multiplication of that. Probability of a equal 1 is what? Reservation is canceled was 10%. So over here, so it's a 0.1 times probability of b equals 0, which is 9. So multiplication of this would be the probability you are looking for. So I mean, one can ask, what is the probability of A's reservation is canceled but B is not? Somebody would say, okay, I mean, isn't just 0.1 because A's reservation is canceled, but you should take into account B's reservation as well. So that was what we discussed briefly last time, you know. So now consider 26 reservation, A through Z. So the probability of canceled is still 10% and still independent. What is the probability that A, B, C, D cancel, but the other not? So, I mean, we discussed something similar last time, right? So also you might want to pause this video. Let's say you have A, B, C, D, E, F, G, Z, something like that. So I'm looking for probability that A, B, C, D cancel, but the others not. So, I mean, some would say, okay, the probability is what? 10%, so 1 over 10 or 0.1. This is 0.1, 0.1, and 0.1. Oh, so answer is basically 0.1 to the first part. Okay, that is our answer. Somebody would say that. But as discussed last time, what is the problem of this? Because we are looking for probability that A, B, C, D cancel, but the others not. So we should take into account the others. The 22 others, they shouldn't cancel the reservation. So we should multiply 0.9, 0.9, 0.9, 0.9, 22 times. In other words, you need to multiply 0.9 to the 22. That is the probabilities. So important. I cannot emphasize enough. Okay. Okay. So based on this logic, these 4 reservations are canceled and 22 reservations are not, so you need to multiply that. So let's consider a general form. Let's say N is total number of experiments, like reservation, and Y is the number of succeed cancellation. P equal probability of succeed. We can generalize something like that. Okay, that is a P to the power of Y times 1 minus P to the power of N minus Y. So that is a general form. Again, that is a P to the power of Y times 1 minus P to the power of N minus Y. So we can apply to here. P was what? Probability of cancel was 1.1. And Y was what? How many observation, reservation should be canceled? It's 4. So Y equal 4. So Y equal 4. P was 0.1. And 1 minus P was what? It's 0.9. And how many N did we have? N was 26. So 26 minus 4 was what? 22. Exactly the same. So this is a formula we are trying to use, okay? So idea is a probability of probability P happens Y times and 1 minus P happens N minus Y times. So those are easy. You know, that is again probability of some events. Like so we come back to the example with the 2 reservation and A, B. So N equal 2 and P equal 0.1. What is the probability that Y equals 1? So can you try to pause this video while I'm erasing this? I mean, also try to go over those questions and try to get the answer on your own. So what is the probability that Y equal 1? So we have a 2 reservation again. That equal what? We have 2 reservation A and B. So I'm looking for probability of Y equal 1. Only 1 reservation cancel. So that is what? Answer is what? So for example, if A cancel reservation, right? A cancels reservation, then it's gonna be what? So it's gonna be 0.1 times 0.9. But what if B cancels reservation? cancels the reservation. It's gonna be 0.1 times 0.9 as well. Because we have two cases, I didn't specify which one should be canceling the reservation. One can, the A can cancel or B can cancel. So our answer is what? Just 0.1 times 0.9 times 2, because we have two cases. Because I didn't specify which one should be canceling the reservation, right? Previously, I specified to you, like first 4 reservations should be canceled or something like that. In the case, we didn't have to multiply these two or some numbers, how many observations or possible outcomes, but now we need to do that. So there are 4 possible outcomes, right? Like that. So A can be 1 and A can be 0, B can be 1 and B can be 0. But we are looking for Y equal 1, so they cannot cancel at the same time, and they cannot, none of them should be canceling. So it should be this one and this one, or this one. So you should add these two. In other words, that is 2 times 0.1 times 0.9. This 2 times would be very, very important concept, okay? So if you know who canceled the reservation, that is the answer. But if you only know the number of cancellation, that would be 2 times. Make sure you guys know the difference, okay? This is very, 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 very important. So, and the difference is 2, capture the number of possible outcomes. So let's consider 3 reservations. So there are 3 cases, right? So if we are looking for Y equal 1, A can cancel, B can cancel, and C can cancel at the same time. B and C should be 0, A and C should be 0, and A and B should be 0. In other words, we need to multiply 3. So just look at this step. What if we are looking for something like 4 reservation and 5? Would it be just 4? Would it be 4 and 5? So try to think about that. In general, N is number of experiments, and Y is number of succeed, like cancellation. P is the probability of succeed. So probability, Y is a binomial random variable following binomial distribution, number of N sample size, and probability. So probability of Y equal is number of possible outcomes times probability of each outcome. So the probability of each outcome, well, this is actually very important concept. Probability of each outcome in previous case was what? 0.1 times 0.9, right? So you need to multiply number of possible outcomes. So probability of each outcome, as discussed before, was p to the power of y times 1 minus p times, to the power of n minus y. This is probability of each outcome, which is corresponding here. How about number of possible outcomes? So these are some of the examples. When y equals 0, because only possible outcome would be 0, 0, 0. But if y equals 1, or number of cancellation would be 1, it's going to be 1, 0, 0, 0, 1, 0, 0, 0, 1, 3. And if y equals 2, it's going to be 3. And y equals 3, it's going to be 1. So these are possible outcomes. You always need to multiply the possible outcomes when you need to calculate y equals y. So probability is what? So probability of an outcome is like that. But you need to multiply those 3 possible outcomes to get the final probability, okay? Let's consider 4 reservations. What should be the case? So n equals 4, probability is 0.1. It used to be 3, but now increased to 4. Try to spend some time on this. I will just leave you the answer, but when you study, you need to pause this video, okay? Remember y is following binomial distribution. This was a probability. So we are looking for probability of y equal 2. So this is your probability, 0.1 to the power of 2 and 0.9 to the power of 2. That is coming from here, this formula, okay? So 0.1 was probability of canceling because you are looking for y equal 2. So this is the case, and then 1 minus 0.1 to the power of n is 4 n minus the y. So that would be 2. So the first part, so now next thing we need to do is find the number of possible outcomes. So there are like 6 numbers instead of 4. So this number of possible outcome is not equal n. That is some logic behind it. It can be 1, 1, 0, 0, or first 2 cancel, the other 2 not, or 1, 0, 1, 0, 1, 0, 0, 1, etc., etc. So there are 6 possible outcomes. So your final answer would be this. Okay. So these are some distribution when y equals 0, y equals 1, 2, 3, 4. So 1, 4, 6, 4, 1, something like that. So these are the complete probability tables, and these are combination rule. So this is something you got to get familiarized this. So during the exam, you are allowed to look at this formula. So, but you got to know how to use it, right? So combination is selecting items from a collection without order. So you can choose 3 topping among 10 options when what is the number of or possible combinations of a topping. So total number of y combination would be like that. So these are the formula. So n combination of y is like that. So n is again the number of whatever reservation and number of 20 the questions, etc. So n factorial. So n factorial is like that. So for example, let me give you an example. So basically, n combination of y equal n factorial over y factorial n minus y factorial. So n factorial, the factorial is like that. So if you have a 4 factorial, for example, it's gonna be just 4 times 3 times 2 times 1. If you have 10 factorial, it's gonna be what? 10, 9, 8, 1, something like that. So these are how the factorial is working. Let's do some simple math. So previously we had a 4 reservation, but looking for y equal 2. So 4 combination 2 was something we were looking for. Using this formula, it's going to be 4 factorial over y was 2. So 2 factorial n minus y is 2 factorial. If you do the math, is 4, 3, 2, 1 over is 2, 1, 2 times 1 times 2 times 1. You can cancel out this one, and you can also cancel out this one. So 2 times 3 over 1 equal 6. So this is how you get 6. You can count it if the numbers are small, but if we have so many numbers, if n equal 20 or something like that, this would be superior to any other method. Okay. So sometimes we denote this by something n combination y, etc. But this would be the thing we're gonna use. So some basic properties: n combination y equal n combination n minus y, and n combination 0, n combination n are both 1, and n combination 1 and n combination n minus 1 are just n. So these are some of the properties you should keep in mind. So if you are getting 5 cards from a standard 52 card deck, how many combination? Using the formula 52 over 5. And notice that why this is a case, because so I'm looking for 52 combination 5. So using the previous formula, what would we get? That would be basically 52 combination over y equal 5 combination times 52 minus 5 is 47 combination. But okay, this would be 52 times 51 times 50 times 50, 49 times 48. 47 and 46 and etc. etc. over 5, 4, 3, 2, 1 times 47, 46, etc. Can you notice something? These last term are the same, so it's going to be always canceled out. So that's why you see the numbers in the slide. Okay, like that. So, and how many combination of all 5 space card in your hands, and this is how you get the numbers. So combination rule were that, and okay, if we have a 5 reservation and 3 of them are canceled, can you try to find all possible number of outcomes? You might want to pause this video again and answer this. So we can do the math. So there are 5. So using the formula, so we are looking for n equal 5, y equal 3. So 5 combination 3. That would be what? 5 combination, 5 factorial over 3 factorial times n minus y, so 2 factorial. It's going to be 5, 4, 3, 2, 1 over 3, 2, 1, 2, 1. Cancel out these numbers. So it's going to be just 10 over 1. It's going to be 10. Okay. Do some maths. Try to go over this many times, okay? So 10 outcome. You can count them, but you might make some mistake if you do this by hand. But using formula, this is how you get that. So when n equal 5, these are the total number of possible, which is 10 times those probability. So that would be your answer. Okay, you got to multiply total possible outcomes times the probability of each outcomes. So that would be probability of y equal 3. And so for the Legend binomial probability distribution, so this, I will just explain one more time of this, because thing you are looking for now is these are the 10 is number of possible outcomes, right? But if you are looking for probability of y equal 3, right? Then you need to get, okay, probability, numbers of possible outcome times probability of each outcome each, right? So that was what number was 10 from here, and probability of each was what? Since you're looking for 3 cancellation, so 0.1 to the power of 3. So that was from the previous formula, and then 1 minus 0.1, which is 0.9 to the power of n minus y. So n was 5 and y was 3, so n minus 5 was 2. So that's why how you get the final outcomes like that. Okay. So that is a probability. So again, but probability is always less than or equal 1. So if your number is greater than 1 for some reason, then you might have made some mistake. So this is general formula for binary distribution. So the first part, n factorial over y factorial times n minus y factorial, those are coming from number of possible outcomes, right? And the other parts are just probability of each outcome. So we have analyzed these two separately, right? Now we are multiplying together. Finally, we get probability of y equal y. So this is how we get the formulas, okay? I'm gonna stop this video, but come back in the following video, because this binomial probability is a little bit math intensive. So I want you guys take your time and look at those lectures. Okay, and then also I'm gonna post a video like a couple days earlier so that you guys have plenty of time, okay?